Welcome everybody to today's Let's Play Finxter episode. Our topic today is the binary search algorithm. Okay, so here we see the code snippet. We have function bsearch, and here we see how we call the function. We have a list L and a value x, and we print the result of bsearch on the list L and the value x. So here we see basically we want to search for the value for the first occurrence of the value x in the list. Okay, in this case, so the naive approach would be just to traverse the whole list. So we check each element whether it is the searched value or not. If it is the searched value, we just return the index of this element. And so this would be the naive approach, which would take us approximately n comparisons if our list size is n as well. Okay, but binary search algorithm is basically much smarter than this. We basically cut the search space by half in each iteration of the algorithm, which makes the runtime complexity logarithmic to the number of elements in the list. We will see what this means exactly in a moment. Okay, so we start with two variables, low and high. These are basically indices that mark the interval in which we search for our value. And low is initially the first element in the list, and high is the last element in the list. And now we iteratively select the mid element exactly between low and high. Here, this is this line. We simply add low plus high and do integer division by 2, which means we select the index of the middle element. And now we check this middle element. Is it smaller than our searched value or larger than our searched value? If it is smaller than the searched value, then all elements between low and mid are basically smaller as well, because this is already sorted. If it is larger, then all the right elements between mid and high are basically larger as well. So in this case, if it is smaller, then we set the new low index to the mid index plus 1, because mid is also the mid element is already smaller. Okay, so we basically have to search only on the right part of the list, because all the left parts are already smaller. On the other hand, if the mid element is larger, then we set the high index to the mid index minus 1, because all the elements between low and mid are basically the candidates for our value. The right elements are no candidates, because they are already larger than our search value. Okay, and only if those are exactly the same, so here this is this branch, our searched value and the value on the mid index in the list. If they are the same, then we go into this branch and we return the index of our current index mid. Okay, and only if we have not returned anything and terminate with this while loop, then we return minus 1, because this means that the element is not in the list. Okay, and okay, as we can see here, we search for the element 6 in the list. Element 6 is at position or index 6, so the result would be 6 as well. Okay, we just put in 6, and we see that the result was correct. Okay, thank you very much for listening, and see you soon.